Okay, so I wanted to talk a little bit more about pressure measurement. I've shown you some slides of the pressure probe, but I wanted to do a more direct demonstration of that to show you how it works, and also to demonstrate that the pressures that animals can generate are much less than the pressures that the plants generate through osmosis and the presence of the cell wall. So what you can see on the left here is a readout from a pressure sensor. This is the pressure sensor here. If I can just show you that, gas pressure sensor, and this works by measuring atmospheric pressure, and I've attached a tube to it, and I can blow into that tube and you can see the pressure that I'll be able to generate with my own lungs. So if I start collection, you'll see that the pressure is just above 100 kilopascals. 100 kilopascals is 1 atmosphere. So if it was below that, we'd say it was low pressure, and if it was higher than that, we'd say it was high pressure. So today's obviously a high pressure day. So 100 kilopascals is 1 atmosphere, or 1 bar. So 110 kilopascals is 1/10 of a bar. Remember, plants in those plant roots are able to generate pressures of 6 bars. The phloem can be up to 40 bars. So that would be 400 kilopascals, 600 kilopascals, and so on. So think of that as the scale that you're working at here. So I'm going to blow into this as hard as I can, and you'll see what pressure people's lungs are able to generate. So even though I'm asthmatic, I'm able to generate roughly 0.15 of a bar. So that's not terribly high compared to what an animal, what a plant can generate through osmosis, as I say, up to 40 bars in the phloem. So we've got a pressure measuring device, and the way the pressure probe works is simply by connecting the pressure device to the plant cell. So here obviously is a plant cell. We've seen this before with the slinky as a model of a growing plant cell. Clearly has pressure in it. In order to measure the pressure inside this cell, we have to introduce the pressure measuring device into that cell. And I'm going to attach through this tube, I'm going to attach a hypodermic needle. Just connect that to the pressure measuring device there. And what we should see, just check the measuring device is still working. And you can see I can still blow into it. So all I'm going to do is introduce the needle, and it won't burst because the rubber isn't very stretched here, just as you would with the pressure probe, but obviously under a microscope, into the cell, and straight away I think, oops, it's just come out, into the cell like that. And there you can see we're measuring the pressure directly inside the cell. If I just expand that scale, you can see it. So the pressure in that balloon is approximately 0.2, 0.15, 0.2 of an atmosphere. Obviously less than I could blow, otherwise I wouldn't be able to blow it up. So that's exactly how it works. We have a pressure measuring device, the gas sensor, which is like the pressure transducer on the pressure probe. We have a means of introducing that into the cell through a needle. It's a capillary in the pressure probe. It's just a hypodermic needle here, and here's the cell there. And we can get the plasma membrane seals around the capillary. It wouldn't work if it didn't. And we can get a measurement of the pressure in that cell. If I squeeze the balloon, you can see we're directly measuring the pressure inside that cell. So that's how the pressure probe works, albeit at a much, much smaller level. The other thing to remember, of course, is for the pressure probe, the cell is a lot smaller than a measuring device. And so that's why, rather than it measuring the pressure directly, what we do is we increase the pressure in the pressure probe to push the cell sap back into the cell, and that's the pressure, the extra stage, that's the pressure of the cell before we penetrate it. And you can see that happening in the pressure probe video.